Welcome to Online Solutions. Thank you for your time. We have a question here. We want to look at it. The procedure has been given. Let us look at it. Weigh exactly 0.5 grams of a diverent metal carbonate. So a diverent, it means that the metal in that carbonate has two valence electrons. The metal has two valence electrons, therefore it is called a diverent. An example is magnesium, calcium is a divalent. If it's a monovalent, it is an element like sodium carbonate, potassium carbonate will contain a monovalent. Therefore, if it is potassium, we will be given T2 carbonate. T2 carbonate, it tells you that this metal is a monovalent. But since this one, there is no 2 here, it means it is a divalent because this one has a valence of 2, and then it cancels out. Put the weighed carbonate in a conical flask, add to it 30 centimeters of 0.5 molar hydrochloric acid. Add 2 to 3 drops of methyl orange indicator. Fill up the purate with 1 molar sodium hydroxide solution. Titrate the solution in the flask against 1 molar sodium hydroxide solution until the color of the indicator changes. So we have been given the values in our table, so we only need to calculate the average. So let us calculate the average and then we shall use that average. So it is 5.1 plus 5.0 plus 4.93. This one is going to give us 5.0 centimeters cube. It's going to give us 5.0. So I like to explain the procedure because once you understand the procedure, then everything becomes simple. So we have hydrochloric acid 30 centimeter. So it means that the hydrochloric acid will first react with the carbonate, and the excess acid, hydrochloric acid, is going to react with another base. This is what we call a back titration question, where we have 2 bases and an acid reacting. The acid is always in excess. That's an example of one example of a back titration. Therefore, so the carbonate will first react with the 0.5 molar hydrochloric acid, and it will take a certain volume of the acid, and the excess will remain to react with the sodium hydroxide. It is important to understand that. So let us look at question B. Calculate the number of moles of the base that neutralized excess acid. Moles of the base. Which base was that? The base is sodium hydroxide, which has reacted with HCl that was in excess. So calculate the number of moles of the base. But we know the molarity of the base. The molarity of that base, sodium hydroxide, is 1. So we will ask if 1 is the number of moles in 1,000. What will be the number of moles in 5? The one that reacted. So 1 is the number of moles in 1,000 centimeters cube of the sodium hydroxide. 5 centimeters cube will contain how many moles? 5 times 1 divided by 1,000. This one will give us 0.005 moles. That is the number of moles in the volume that was used, the volume which is 5. Determine the volume of excess acid, hydrochloric acid, that neutralized the volume of sodium hydroxide. So we want the volume of excess hydrochloric acid. It is easier to do that because now we know the relationship between sodium hydroxide and HCl from the equation. You must write an equation for you to understand this, or to get this. Sodium chloride, water. So the ratio is 1 to 1, that's obvious. But we have the number of moles of, this is 5 centimeters cube, and the number of moles is 0.005. That one we know. Yes. Now, since the ratio is 1 to 1, it means that the number of moles of HCl that you used that was in excess is this. So moles of excess HCl equal to 0.005 because the ratio is 1 to 1. Now, if we have the moles of HCl, then automatically we are going to have the volume that was in excess. How? We know the concentration of HCl. HCl was 0.5 molar. This is the number of moles in 1,000 centimeters cube volume. Now, what will this 0.005 contain? Now we will get the volume like that. We will say now that 0.5 is the number of moles of HCl which are contained in 1 liter, 1,000 centimeters cube. Then we will ask 0.005 these moles will contain which volume, because we want the volume. So 0.005 times 1,000 divided by 0.5, and that one will give us 10 centimeters cube. So it means that 10 centimeters cube reacted with sodium hydroxide. So we can easily get the volume that reacted with the carbonate, because the total volume was 30. So 30 minus 10 will give us 20. So 20 centimeters cube reacted with the carbonate. The acid which was in excess is 10 centimeters cube. Calculate the volume of hydrochloric acid that reacted with the carbonate, hence determine the number of moles of HCl that reacted with the carbonate. And that one is simple because the total volume of HCl was 30 centimeters cube. So 30 minus 10 equal to 20 centimeters cube. So 20 centimeters cube reacted with the carbonate, and the 10 reacted with sodium hydroxide. Now the question is that determine the number of moles of HCl that reacted with the carbonate. Right, we know the concentration of this. So 1,000 centimeters cube of HCl is contained in 0.5 moles, because we know that from what we are provided with, 0.5 molar hydrochloric acid. We will ask 20 centimeters cube will contain which moles. So it is 20 times 0.5 divided by 1,000. This one is going to give us 0.01 moles. So the moles of the acid that reacted with the carbonate is 0.01 moles. That is the acid. Determine the number of moles of the carbonate that reacted with 20 centimeters HCl. Now we want the number of moles. Now there we need to write the equation so that we can see the relationship between the acid and the carbonate. M carbonate plus it is going to be 2 HCl. It's going to give us M chloride plus water plus CO2. So we can see clearly that the ratio between the carbonate and the HCl is 1 to 2. But we have the number of moles of this, the HCl is 0.01. So it means that the number of moles of the carbonate is going to be a half that of the HCl. Mole ratio of the carbonate to the acid is 1 to 2. Therefore, moles equal to a half times 0.01, 0.005 moles. 0.05 moles of the carbonate. Determine the relative formula mass of the RFM of the carbonate. RFM. Always, you should know the formulas. Mass, moles, RFM, mass. Now we want RFM. RFM is equal to mass over moles. Mass over moles. The mass of the carbonate was, so we go back, the mass is 0.5 grams. So the mass is 0.5 moles is here 0.005. This one will give you 100. We give you 100. The RFM is 100. Determine the relative atomic mass of M in that salt. So M carbonate, the total RFM here equal to 100. So M plus 12 plus 48, that's 16 times 3, will give you 100. M plus 60 is equal to 100. So M is equal to 100 minus 60. So M is equal to 40. M equal to 40. Thank you. Thank you.